Good afternoon. Thanks for coming. I'm Bob Florian. I've been with SmartThings almost 5 years now. So before the acquisition by Samsung, and through the acquisition, working closely with them to bring you the SmartThings cloud that you've all heard so much about. Today, we're going to be talking about one of the ways of several ways of connecting to the cloud. You can, if you have Z-Wave, Zigbee, LAN protocol devices, they can be connected to the cloud through our hub or through a router or security panel that has SmartThings inside. As you just heard, if you were in the last session, there's also the ability to connect devices directly to the cloud. If you see some of the literature and you've familiar with SmartThings, you may see there's a subtle distinction of parsing here where we have cloud-connected devices, which is the middle bullet here, which are devices that connect directly to the cloud. And they're what we call cloud-to-cloud connected devices, which is what we're talking about today, where you have a device that already has a connection to the cloud in its own ecosystem, but through something called a SmartThings connector, we'll allow you to connect that device to the SmartThings cloud and to have it participate fully in the ecosystem. How many people here, we have anybody that's done SmartThings development at all? Wow, okay. Arctic development. If you're familiar with either of those, you might ask, so haven't you been doing this for years? And we have. But we're now consolidating the approaches and we're addressing some limitations, particularly with the Groovy Smart App approach that we've used to date. If you've ever used them, Groovy Smart Apps are really fun to do simple things. You can do them quickly. We have a rich, vibrant community. Some of you might be in it that have done very not simple things with them and have pushed them about as far as you can go. Because there are some limitations. It's one source file. I think 11,000 lines is our record. And you know, there's not really support for a wide range of automated tools and testing frameworks. There isn't the ability to pull in third-party libraries. And so we're addressing some of those limitations with the new approach. It's REST API based. It moves your code out of the SmartThings platform and allows you to use any language, any web framework. You can take advantages of all the code features and libraries. And it also moves SmartThings out of the maintenance loop. So previously, we had to be involved for substantial changes to a device integration, and now that'll be left in your hands. Hosting-wise, we have specific support for AWS Lambda. And you can also host it on any sort of web service, including one running on your laptop, but only in testing mode for that, probably. That can be like a third-party web service that uses a published API to this external cloud and integrates that way. Or it can really, if you are a device manufacturer, you already have a cloud, that connector can actually run in your cloud and connect directly to SmartThings without the third-party smart app that we have now needing to be involved. So we're going to look at a little more detail about what you actually wind up doing in order to create one of these connections. The connector definition is pretty much the same sort of thing you'd see with any sort of REST API where you register your app, what it does and how for us to reach it. Device profiles are the way you characterize your devices and how they are going to be represented in the SmartThings ecosystem. And then there's, of course, your implementation. We'll look at each of these in a little more detail. Device profiles really determine how the rest of the system sees your device. And you've been hearing about the wide variety of clients that'll be running on phones and refrigerators and et cetera. Automations, rule engines, voice control. The device profile defines how your device is represented in all those in that ecosystem and how it's controlled by those things. And it allows it to participate fully, even though it's connected through your cloud. It also forms a contract that you need to provide certain things, And some of those are required and some are optional. We generally have rules around what optional means. So like in this example, we might have a color bulb. It has a switch level, color control, and we'll get into some more detail about what those capabilities are later. The profile's decomposed into one or more components and one or more capabilities. The capabilities are really the atoms of interoperability. So that's what allows your device to be used by any of these other systems in a consistent way. They define the details of the contract. Here's like an example of a set level command for a dimmable bulb. You need to obviously specify a level. The rate is optional, and so your implementation would have to accept that rate, but if your bulb doesn't support dimming rate, it doesn't really need to do it, but it has to honor it so that it plays according to the contract with the rest of the system. Components allow you to break a device down into multiple instances of the same capability. In most simple devices, this won't be needed. If it's a bulb, it'll have a switch, and switch level capability. But more complicated devices need to have multiple instances of the same capability, or at least that's the way we prefer to model them. And so in this case, a refrigerator, pretty much any refrigerator these days, has a cooler and a freezer compartment. They each have a current ambient or current temperature in that compartment. They have a set point that controls what the target temperature is, and the contact sensor is really an open-close sensor. They have a door that can be opened and closed. And we model that with components and capabilities so that any automation or user interface element that understands temperature measurement, for instance, can be connected to this refrigerator. If we had modeled this with a freezer temperature and a cooler temperature, then those would be considered different things. And so the component capability model promotes the most interactivity among other systems. Even simple devices have at least one component. It's called main by convention. But you can have a device that has a main component that represents the device as a whole and subcomponents as well. And so if you had a 6 outlet power strip that had 2 individually switchable outlets, you could have a main component with a switch capability that would allow automation to turn the whole power strip on and off. And you could have each of those switchable outlets also be a component with a switch capability. And so the user, when they're configuring that role or automation, could pick which component they want to control. The connector implementation, it's an event-driven system. There are several classes of events. Typically, there's some sort of authentication and authorization, so there's an OAuth journey that's done there, and your connector needs to handle its end of that interaction. There are create, update, and delete lifecycle events, and I just saw now that the arrow is backwards on that that diagram. So those are actually events that come from the SmartThings cloud when you install your app, when you update its preferences, or when you remove the app from the SmartThings system. And so that's telling your connector to do the appropriate thing with its devices. And then, and now I'm talking specifically about cloud-to-cloud connectors, they're responsible for sending to the SmartThings cloud device state change events when a switch turns on, refrigerator temperature changes, etc. And they subscribe to and receive from the cloud device events. So if I actuate the switch with the SmartThings app, or a rule turns on the switch, that will result in an event coming to your connector from the cloud. You can make this connection from the user interface, user experience perspective in 2 different ways. On the left here is the SmartThings app. There's a catalog and a marketplace, and you can have an entry there, and you can initiate that journey, out from the SmartThings app. Typically, there will be some sort of OAuth or authentication process to validate the connection to the external cloud. The third of the screens there is in the middle is a configuration page, and this is something that your connector can choose to do. It doesn't have to do this, but if you want the whole installation process to appear in the SmartThings app and to have the right look and feel and work across all the variety of clients that we may have, you have that option for handling configuration of your app that way. And finally, when you hit done and install it, your connector will use those REST APIs to create a device that shows up in the SmartThings ecosystem that's completely interoperable with everything else. And so you could have a rule that turns on your cloud-connected bulb, a Zigbee bulb, and a LAN-connected Hue bulb all at the same time, and any app that deals with those three bulbs can deal with them in the same way. The other option is if you have an app that you use to onboard the device or for some other purpose, you can do OAuth into SmartThings. And so you can initiate that from your app. You would, in this case, there would be a couple of OAuth pages from SmartThings that would let you authenticate with SmartThings. And then the rest of the user experience here is up to you and can be built any way you desire in your app. The end result is the same. Your connector will make REST calls into SmartThings to create the devices that represent your ecosystem. The connector definition, this is something that will be done on the dev workspace, which I think will be launching soon. It's pretty typical of REST. Of a REST API, app registration. There are a few extra things. You need to identify your app. We have special handling for Lambda that reduces the amount of work you have to do in AWS. And so you specify whether this is going to be a Lambda or a web service app. You give the target where we can find your app. The last two things we provide to you, OAuth credentials if you're doing OAuth into SmartThings, and also a public key that's used for validating these events, which you're getting as REST calls to make sure it's us calling you and not someone else. The connector implementation is an event-driven system. You specify one endpoint that gets called for every event. Here you can see an expansion of my earlier diagram with event types. The ping event, you get when you first register the URL of your app, just to make sure you're there and alive and working. Configuration event, you may get multiple of these. This is what drives those configuration pages I was telling you about. There's an OAuth callback. If you're doing the OAuth out from SmartThings, we handle kind of the shell of the UI for you and give you the information. The result of the OAuth redirect comes back, and we give you that information in this event callback from us, and you can use that to complete the authentication. The next three are install, update, and uninstall, or these lifecycle events where you'll get install the first time you connect your app, your cloud. You'll get an update anytime you change one of those configuration pages, and you'll get an uninstall if the user ever removes your app from the SmartThings. The last event covers all the kind of in-life operational events. In the case of cloud-connected devices, you'll be receiving device command events here. So every time someone actuates something on an app or a rule runs something that's talking to your device, you'll get a command event there. The next session is going to be talking about automation apps, and they also get events through this channel, but they would be actual device state change events. So we were inspired. At this point, we want to show you some code, and we were so inspired by the success of the live demos at the keynote this morning and the risk that was taken there that we thought we'd try it again. So at this point, I'm going to turn things over to my colleague, Vinay. He can introduce himself and do all the hard stuff here.
Okay, I'm Vinay Rao. I joined SmartThings about 3 years ago. I'm going to try and hope that the demos work. So we'll try to switch over to my laptop now. So the first demo that we have lined up for you is Slack. It's the easiest way to represent both what a command and an event would look like. So in this case, what you can see is there's an actionable button here. So if I click on that, you'll be able to see that my status here goes from green to away and back to auto again. This is the command aspect of it. I will run through the whole demo and then go into the code. The second part is where Bob and my colleagues coming, and as soon as someone pings me on Slack, this part of the demo, okay, almost there. No. No, we've got commands working, but events not so much, so we'll try that again. For now, let me tell you, this is what events look like. I tried to monitor how many times do I get messaged in a given day, and it's about 251. And we'll try to see if we can get that part of the code running again. But the two aspects of a device integration would be command and events. So the first aspect is commands. So whenever a command, like in this case, when I clicked on that button, it generates a switch on event. And it tells the integration that, hey, you need to go ahead and turn the switch on or off. And all that's doing is, as part of the integration here, it just goes in and sets my presence value. So it could be on or off, and based on that, it's actually setting the presence value to auto or off. So that's the flow from SmartThings all the way to Slack. And the other flow is the event aspect of it that I will try to jumpstart again. Let's see if we can get events rolling just one more time. So, yeah. And in this case, we finally have one event come in. And the easiest part of this is it doesn't matter if I wrote it in the endpoint app model. We could use our existing Groovy Smart app, and all it does is turn the light on. And if I decide to reset it, it should turn the light off. OK, that worked. So the idea here is the event is generated on the Slack side. You've got an event on your, whatever your cloud device is, that's generating an event, and you need to tell SmartThings from our capability model that an event has been generated. So the way we do that is, for the Slack example, we have a callback. So every time there is a direct message that comes in, all it does is calls a callback, and we do a bunch of checks to make sure that it is Slack. And once we're done with that, it's nothing more than keeping track of what the message number is, and then creating turn this off. Creating the level event here. And based on that level event, you could have a smart app or an endpoint-based smart app that would be covered in the next session on how you could subscribe to that and turn on an existing Hue bulb in this case, or a Zigbee bulb, or so on and so forth. So one other advantage of moving away from Groovy and doing this is I drive a Honda, and it has an OBD port where you can connect an OBD port or OBD dongle, and it will tell you using a Dash app whether the car is on and off, or if the fuel is low. So this is what that would look like. But the idea here is I don't need to go and turn my car on and off. Because we are outside the Groovy model, I can easily mimic these events just to make sure that my code is working fine. So once the events do come in, it would work. So let's see if I can get that to work. So my car is off right now. So let me. So once we get that going, I can, because I have stubbed the code out, turns the car on, and this should. So the idea here is, in today's Groovy model, this is not very easy to do. But here, because I control the whole environment, I can have the commands come in and create something, and at the same time test out that my integration is still working without actually dealing with the physical device and turning it on and off. So this is a basic integration. What we thought was it would be a bit more cooler if we could not write any code, and that's where our zero integration comes in. So the big power of moving away from Groovy, and as we said, using existing libraries is you may not have to code at all. All that you would be doing is taking an existing library integration and mapping it to SmartThings, where you're not really coding the integration anymore. And the example for that is a Tesla. We've got node integrations where someone put up a node package called Tesla API, and all I had to do was npm install Tesla API, and all that this is nothing but mapping Tesla events to SmartThings events and SmartThings command to Tesla commands. To see if this actually works, Tyler, are you there?
I am. Can you guys hear me?
Yeah, we can hear you. We can't see your video feed.
Hey.
Okay, let's see if your video comes back. Okay, so we've got Tyler here at our office at Samsung Research America in Mountain View, and that's his Tesla that he trusted me with the API tokens to play around during this weekend. So let's see what we can do with his Tesla. So right now, the car is off, he's outside. It's pretty cold there, so the internal temperature is 59. He probably drove around somewhere in the afternoon, so the battery is at 70%. The doors are closed, the car's locked, and we can take a few actions. Let's see if we can honk his car. Yeah, so the lights did flash. Okay. A little delayed, but the idea is we can control his car. So if Tyler now steps into his car and turns the AC on, let's see how that goes.
All right, AC should be on.
Did you turn it on? Yeah. So the AC status has updated here for AC cool. The car's not started yet. It's now starting to warm his car up, cool his car down to 76, and yeah, the car's unlocked. So you can see the status here that the car's unlocked. So just so that we can end it on a bang, let's see if I can honk his car again. Okay. So thank you so much, Tyler, for trusting us with your car over the weekend. Hopefully we made it worth your time. And the key part here with this whole integration that we have working right now is I can show you this code over and over again and show you how there is no code involved here from a Tesla point of view. I have no idea how. I think we've gone back to.
Oops, sorry.
So I'll just show you the code again. We have no idea about how the Tesla part of this actually works. All it does is maps Tesla events like climate control or door status or battery to SmartThings events. It's actually doing nothing other than calling the library. And it's as simple as, in this case, it was someone wrote the Tesla-API and put it under MIT license, and I was able to use it to create a Tesla SmartThings integration in half a day. And the idea is, because it was in Node.js, I wrote it in Node.js. If it was in Go, I could have tried Go or Python or whatever. And for us, that's the big hope. The hope is we've seen our community push our integration with just Groovy to 11,000 lines so that they could have the coolest automation. We can't wait to see with a power like this where they can go and use existing libraries to create integrations on what they would create. So that's a big hope for our community and our developers. So thank you so much.
Questions?
We have about 5 minutes for questions. Does anyone have right over here?
Hey, Vinay and Bob. Well, great job. So I have a few questions. So the Tesla integration that you did,
Yeah.
you said the translating the capabilities or the events between Tesla and SmartThings
Yes.
was not too hard.
Yeah.
Would you tell us a little bit about their kind of maybe capability or event model? Like, was it really that intuitive?
Yes. So the idea is, for most of the integrations out there, it's nothing more than just interpreting what that JSON looks like. If I was actually doing a Tesla integration, I would actually have to understand how that JSON works and what their command structure needs to look like. But the idea with this library was, all I had to do was Tesla.get battery status, and in the callback handler, do a data.battery. And that's it. I wouldn't have to go parse anything, and it's almost all of those are documented as part of that library. And it's, again, one set of community developers that decided, hey, we need to hack our car and create an open API. And there's one set of developers on our side that decides, hey, let's try to see what we can integrate into SmartThings. It's just linking the two together. There's no amount of understanding what needs to be done. It's just looking at the documentation. I saw what was possible and where it could integrate, and it was just about 50, 60 lines of code that would just translate from one to the other.
And in this case, it was an open source node module, of which of course there are a lot. But if you had already had a cloud and you were a device manufacturer, this would apply to your own libraries. And so the current SmartThings Groovy smart apps have a pretty nice interface for doing RESTful API calls, but you're back down to the level of paths and REST APIs. And if you already have an infrastructure and you already have libraries that expose these things, what we're moving to will allow you to leverage those things.
All right, do we have any other questions? I guess we're good, gentlemen.
Thank you.
Thank you very much.